कि इंग्लिश में होगी क्योंकि यहाँ पे ऐसे बहुत से लोग होंगे जो जिनको उर्दू ज़्यादा सही समझ में नहीं आती होगी, यंगस्टर्स वगैरह। ठीक है जी। और सो विल स्टार्ट दिस। Okay, so this is what I'm going to do. We're going to study about networking. I was thinking more on the lines of CCNA, but I was looking at the Excel file which Ziabai has sent me, and I noticed that half of you are basically not in IT. Like only 30% of the people were in IT. So that's why what I wanted to do is just give you the basics of networking. If someone has any other information like they want to get from me, then I can, send them the documents. This document where I'm going to be teaching from, this is I created this, and you guys should all have the copy of this. You can download from the Teams, right? Any questions? You guys can ask me any question now so that we can start. So all the videos and audio must be muted. And if you have any question, then you can just, enable your audios. No one has any questions? Okay, so I'll start then. So the first chapter, I have actually put this PDF together because I've been teaching at Humber College for the last 14 years, only part-time. So, I work in an IT company, a US-based IT company. So where I'm like a network admin and security analyst both. Right. So this is I created for my students for Humber, and also, I teach from the Cisco Academy because I'm a certified instructor for Cisco. Okay, so let's just start from the very basics, which is fundamental of networking. Why do we need networking? Networking is anything basically if you're trying to send information from A point to a B point. How would you be sending the information? Let's suppose I'm sitting in Toronto and somebody else is sitting in Montreal, right? So if I have an office in Montreal, then how would I be accessing the server which is sitting in Montreal? So we as a network admin, we as an architecture, we design this whole network, whether the routers should be in place, switches are going to be in place, how the PCs are going to get connected to the switches, that kind of stuff. And I'll go in more detail what the routers do, what the switches are, how we get connected to the switches, and what cables run from the PCs to the basically switch, right? So let's look at this first chapter, which is the fundamentals of networking. So this is the example I was giving you that if you're, let's suppose you have a server sitting in Montreal and you are in the Toronto office, then basically how would you be connecting to a switch? And from the switch, you'll be connecting to the router. And through the router, basically you get connected to another router, which is sitting in Montreal. So let me just draw this here in order to explain you how this system, how this works. So let's suppose this is my Toronto office. Let's suppose this is my Toronto office. I have got a router. This router is a layer 3 device. What the layer 3 device does, it basically works on IP addressing. This IP addressing will be coming probably in chapter number 5 or chapter number 6. So I'll go over what IP addressing is. So just for now, the router connects to a switch. This is just an overview. And each switch, you have a PC connected, right? And then from Toronto, you will need a connection which would be going to the Montreal site. At Montreal, you will have a router sitting here. You will have a switch connected here. And then you will have, let's suppose, a server sitting here, right? So how does this connection works? This is basically done by an ISP. So let's suppose when I'm sitting in Toronto and I said, Rogers or Bell or TELUS, give me a connection. This is my address. I need a 5 meg or a 10 meg connection between my offices in Toronto and my office in Montreal. They say, okay, no problem. Give us your address. We give the address, whatever the address is at 151, sorry, at 151 Front Street, right? And we say whatever the address is, X, Y, Z. in Montreal. So what they would just simply do, they will give you a cable in Toronto, and will give you a cable in Montreal, and will say, here you go, this is your 5 or 10 meg, whatever you have requested, right? And we simply connected these two devices together through the cable from an ISP, and basically we will have a direct connection. Then we will apply IP addresses. As I said, IP addresses I'll explain when I get to chapter 4 and chapter 5. But this is usually the layout. This section, which is here, locally sitting, is called LAN, local area network, which is basically locally sitting at your place where you are sitting. This section, which connects the Toronto and Montreal, this is called WAN, wide area network, which is a remote site, not your local site. This is a remote site, right? So this is the difference between a LAN and a WAN. LAN is local, WAN is remote connection. So the remote connection, because you see now, before we used to get a T1 circuit. T1 circuit is like 1.54 meg. But now even in households, you don't get 1.54 meg. You get what, 200 download, right? 100 meg download. Because why? Before, we didn't had any voice over IP capabilities over these lines. When I say voice over IP, you know that IP telephony system? What IP telephony system is, that if you're sitting in Toronto, you will be connecting to a voice over IP phone. You will be connecting your laptop with the voice over IP phone. Your voice over IP phone would have a cable coming in and would be going into the switch, right? And then from there, it will be using your voice and your data. They both are going to be using the same pipe in order to send the traffic from one end to the other end. So why this voice over IP is so famous is because if you have an office in Toronto and you have an office, let's suppose in Germany, you don't have to pay a long distance fees, right? All you can do is just pick up your voice over IP phone and you can make a call using the same bandwidth, using the same link. So that's why in the beginning, we were having 1.54, 43 meg pipes. But since the new technologies are coming along, the voice is coming, video is coming, your data is going. So everything is basically jumbled up in a pipe, right? So if it's jumbled up in a pipe, that's why we need higher bandwidth. I'll give you an example. At your home, you have your tablet, you have your cell phone, you have your laptops, everything is basically connected, right? And if you're having a voice chat with somebody back home, what you're doing is basically your voice is also going through the same pipe, your Rogers or your Bell, and also your data. If you are, watching something, or if you're sending an email, so your data is also going, and your voice is also going, your video is also going across. Understood, guys? So this is the WAN portion. This is the LAN portion. LAN is local. WAN is the when you're connecting remote sites together. So this is an example. And in order also to understand this LAN switch and run router, I'll give an example of your home, how your home is set up. So this is how your home is. At your home, you have this router sitting at your home, right? This could be from Rogers, could be from Bell. Now, what is happening, if you look on the back of your router, this Rogers Bell router, they're going to be calling it, you have those three ports here. What are these three ports? These three ports on the back of it acts as a switch. So when I say switch, which means that you have an RJ45 cable coming out of it and going into your laptop or your desktop, and your desktop has a NIC card in it. And now these NIC cards could be a Gigi card or a fast Ethernet card. right? So the fast Ethernet, remember, can be 10 meg or 100 meg, okay? And something called duplex. What is a duplex? This is a full duplex. So the duplex is basically saying I can send full duplex, I can send and receive data at the same time. That's what full duplex is. So either on your laptops or your PCs at home, you might have a fast Ethernet card, or you have a Gigi card. And what a Gigi card, what is the speed of the Gigi card is? 1000 meg or 1 gig right here. Understood, guys? So you might have a NIC card. You'll definitely have a NIC card coming from here and going into your Rogers box at home. You have 3 ports usually. Before they used to give you 4 or 5 ports. Now I think they have cut it down to 3 ports. Because why? A lot of basically routers, they're coming up with wireless, right? Because people have got their cell phones, people have got laptops, which is like all wireless and everything. Now this box itself works as a router. It works as a switch. It works as a wireless router. It works as a DHCP. I'm going to explain all this later on, but I'm just giving you an example for now. Understand what the router does. Switch, this will act as a switch, right? These 3 ports, which connects to your NIC card on your PC. Router, this is the one which will decide where you want to go to. So let's suppose I want to go to www.bbc.com or www.cnn.com or youtube.com. So my router at home will decide whether I know how to get to them. Understood? The router is the one which decides where this person wants to go to, and he should have a route. He should know how to get to it. Otherwise, what would happen? You'll probably be able to go to yahoo.com, bbc.com, but cnn.com and youtube.com you're not able to go to. So what the first thing you're going to do? You're going to call your basically your telco, your Rogers or Bell, and say, you know what? I cannot get to youtube.com, right? So what is going on? Then Rogers will have to look into your router and see, what is wrong and how this routing, this whole pack in information sending from the source to the destination is called routing. Routing is sending information from source to destination. This destination can be anything. Yahoo, CNN, BBC, whatever you want to call it. Understood, guys? So understood the role of a router. The job of a router is take your traffic to wherever you intended to go. The role of a switch is basically you have a NIC and it will act as a switch port. This is not a wireless. Wireless router is what? Same thing as this router does. The only it will give you a wireless connectivity. That's all it does. Give you a wireless connectivity for your laptop, for your tablet, or for your cell phones. Now, the next one is DHCP. It's going to be too soon for me to get into DHCP, but DHCP is basically the one which allocates IP addressing because any communication happens on the internet or within the LAN, it's all IP addressing. How many of you are aware of IP addressing? I need to understand this so that, I know exactly how to go about. How many of you are comfortable with IP addressing? Okay, I got one, two, three, four, five. When you guys are raising your hand, does that mean that you guys uh, know about it or what?
Yes.
Okay, Please explain. Somebody wrote something. Let me look at it. Oh, sorry. Here you go. My apologies. I wasn't not looking at the messaging chat. When you say speed of a gig card, what do you mean? Can you give an example? Okay, card come in a variety of speeds. Gig card is the speed of in gigabits, and that meets the current standards. Okay, you have answered it. What's the difference between a modem and a router? Please explain as not comfortable. Okay. Okay, so basically, first of all, my apologies that I didn't look at the meeting chat. What you guys have been saying. So I'm gonna switch it to the meeting chat. I know about IP addressing. Okay, but I noticed that only like 6 people know about IP addressing. I will go over it, guys, a little bit, not too much, just to get you guys to understand exactly what it is. Okay, and what's so basically the Rogers, they call their box here as a modem, right? But we don't call it a modem. We call it a router, because a modem is what we used to use, like when we were dialing into a device. Let's suppose I'm here in Toronto and I'm managing something in Vancouver, right? So I do not know what the status of the router is. I want to get into the router. I want to get into the switch. I want to configure something there. So for that, I will just dial into with the phone number into the modem remotely, and that modem will be connecting me to the jump server. And from there, I'll be able to jump on different, we call it a jump server. It's called network management routers. And then from there, I'll be able to access different routers and different switches, whatever I want to get in, I can get in through there. But Rogers call it a modem, but the correct word is not a modem, it's basically a router. Understood, guys? Because router is the one, the first 2, 3 words are what? Router, route. Route is what? Take your packets, take your information from point A to point B. That's what router does. Understood, guys? Did I answer this? Yeah? Okay, so that's what it is. So basically, when we are having another thing, I want to bring it up, convergent networks. What do we call convergent networks? So when you have this router, I'm going to call it a layer 3 device. And I'm going to explain the layer 3 device later on when I talk about the OSI. I'll talk about it. So layer 3 device only works on IP addresses. Okay? And this connects to the switch, and this works on layer 2, and this is layer 2 is MAC address. Understood? And this is where your PC is, connects to your NIC card, wherever your NIC card is here. Okay? So on the switch itself, let's suppose if this is a switch in this example, and switch has got ports 1, 2, 3, 4. It can go up to 48 ports or 24 ports, right? Depending on the type of vendor, depending on the type of ports you have. At home, you will have, as I said before, at home, you will have in the back of it, you will probably have 2 or 3 switch ports, not more than that, right? This is where your NICs are going to be going into, your NIC card cable, straight through cable going from your PC, going into the switch. And each NIC card has a physical address. What this physical address is called, it's called a MAC address. Now, if you go to CMD, like this. If you go to CMD, if you type CMD and enter, and you do IP config space / all. Now, if you look at this, I'll mark it. If you look at this, this is the physical address of my NIC card. What this physical address is basically the address on my NIC card. Understood, guys? Something has to have an address, right? Even like when you talk to me and you ask me, what is your name? I'll say, well, my name is Imtiaz Hassan, or Imtiaz, or Hassan, whatever, or Syed, So everything has to be identified. So your NIC card is being identified by these numbers right here. This number is called physical address or a MAC address. This works on a layer 2 scenario. This is layer 2 scenario. And when we talk about IP address work on layer 3, your router, and everything on the internet or any networking, everything works on IP address, right? Everything basically gets identified on the internet with an IP address. I'll give you an example. So let me just show you this. This is my IP address right here. Mark, this is my IP address. I'm going to talk about subnet mask later on, guys, because I don't want to lose you guys if I give you too much information. And this is my default gateway. So this is my IP address. This is my subnet mask. We'll discuss it I think in chapter 5 or chapter 6. This is my default gateway. This is my physical layer 2 address. MAC, as I was saying here, this switch is a layer 2. This is my layer 3. IPv4, this is my layer 3, which is this one. Now, when I go out on the internet, I don't want to get into NATing right now, but when I go out on the internet, I need to get identified by something on the layer 3 level. This is how I'm going to get identified on a layer 3 level by an IPv4 address. On the layer 2 level, this is how I'm going to get identified with this address. Understood, guys? Now, let's suppose, and as I said earlier, that everything gets identified on the internet with an IP address. If you don't have an IP address, you will not be able to communicate with anybody. So let's suppose if I want to go to the bbc.com, right? What is bbc.com? If I do ns lookup, www.bbc.com, this is an IP address of the bbc.com right here. This is the IP address of the bbc.com. So which means bbc.com. So you have to understand, when I talk about DNS, then I'll talk about this bbc.com and the IP address. But for now, just understand this. At this time, just understand this point is everything gets communicated on IP address and nothing else. So how come I can go to www.bbc.com and I can get to the BBC website? That's where the DNS comes into. We'll talk about DNS later on. But just for now, just understand this, that any communication happens on the internet or anywhere within your LAN, it basically happens on your IP addressing, which is this one, 151.101.124.81. Okay, how this comes into play, what is this address, what is this class A, class B, and class C address, what is this whole subnet mask, it's going to come later on. This is just a little overview for you guys. I'm not going into details, but understand layer 3 router, layer 2 switch, your NIC basically gets connected to the switch, and then basically from the switch it goes to the router. Okay. Let me see if anyone has typed anything here, if I have not missed anything. Is there a way to make your computer screen larger so that it's easier to read? Is everybody having this problem, or I thought I had? This is large enough, isn't it?
good enough.
Yes. Okay. Okay. Click on three dots and click on the full screen. That will help. Click on. This is full screen, my friend. I cannot go more than that. Okay. So let's look at this. We talked about what router does, as I just said. We talked about what switch does. We talked about what voice over IP does. You see, this design is not correct. What voice over IP, how this is is basically set up is like this. You have a phone. I've got a, I got a horrible, think of this as a phone. Horrible picture, but it would work, right? You have a laptop. This is a phone, right? You have a laptop and port gets connected over here. Then there is another port which comes here and goes by the wall jack. And from the wall jack, it would be going into the computer room in a switch. Could be one, could be two, could be three, right? So basically, when you pick up the phone and you're talking to somebody or you're dialing, remember, as I said earlier, what did I say earlier? If you're in Toronto office and you're going to Montreal office, and a switch, and you got a PC sitting here with the voice over IP phone. So what happens when you're picking up the phone and you're dialing somebody in Montreal office, you're using the same bandwidth as your data is going across, right? That's why this voice over IP is famous, because people are saving money in long distance, right? So this is called converged network. Converged network means that you're mixing your voice, you're mixing your video, you're mixing your data, and everything is basically going in one pipe, which is this pipe right here between. This is what is this network? This is wide area network. My WAN, remote, connecting two different sites, could be in different continents, could be in different cities, could be in different. Even if I'm sitting in Brampton, I'll be connecting to Scarborough office. That's considered to be a WAN, so my remote location, not my where I'm sitting in at an office or at home or something like that. That would be considered my LAN. Okay, so host is basically as a PC. PCs are basically host, right? Client server or both. Software determines the role, if it's a server or a host. So basically that's what hosts are called, PCs. Servers provide information services to clients, email or web pages, or basically it's your repository where basically you upload your files, whatever you want to upload it. So these are the devices I was just explaining. You've got a server sitting here, you got a switch PC sitting here, and you got a voice over IP. This IP means voice over IP. This interconnecting routers, this is basically different routers you're hopping through. I don't want to get into more detail. I'm going to probably confuse some of you guys here. So that's why I think of it as one router here and one router here. So could be your Toronto, this could be your Montreal, right? So that's how it is. But let me ask you something. When I call Rogers or Bell or Telus and I say, you know what, give me a connection in Toronto and then give me a connection in Montreal, right? And then what do you think, that there is one cable running from Toronto to Montreal all the way through? No, they have got central offices in between. It basically goes into multiplexers, go into muxes, and then basically gets terminated there. Everything is underground, right? And then from those central offices, it go to a different central office. And then from there, it will go to a different central office till it gets to the destination in Montreal. So if you have an office in Toronto and then you got an office in Vancouver, how are you connecting between these two sites? It's all cabling, right? You're not using wireless. It's basically all cabling running underground. It's not one cable. It's basically cable running. Probably after 5, 10 miles, they will have a central office. Then from there, underground, there's a cable running, goes to another central office. Then from there, all the way down to Vancouver. So if I need to send something, let's suppose I need to send, I'm having a chat with somebody on my WhatsApp or on my PC, right, on the messenger, and I'm sorry, what is this? How do VPNs work? Uh, right now, actually, I don't want to talk about VPN. I'm going to probably answer this later on. Okay, Sheroz, I'm going to keep in mind, but let me explain the points I'm trying to make, and then I'll get on the VPN part. Okay, so let's suppose I have basically what I was saying. Let me backtrack it. I'm talking with somebody. I'm having a chat, and I'm talking with somebody in Pakistan, right? On a messenger. So when I type hello, how do you think that my hello is going from Toronto all the way to South Asia? It's going through cables, right? Now you're gonna say we got oceans in between. How are you running a cables? If you go on Google, you're gonna find how they are running cables in the ocean, right? So from Toronto, from New York, we have got cables running and going to Africa, going to Europe. Then from Africa, you have got cables going from there to Middle East. From Middle East, it's going to South Asia. Then it's going to Southeast Asia. Then it's going to Australia. So if I show you here, so under undersea cabling. You see these cables? This is how they run the cables in the ocean.
Please share
This
your.
is, I'm sorry?
Please share your screen.
I think I'm sharing my screen, isn't it?
You're sharing
Proceed.
yourself.
Can you guys see it now?
Yes, yes. Now it is there.
Okay, sorry. I don't know. I might have clicked on something which, stopped it.
No, only your photo was there in the center, but now it is good. Yeah.
Okay. So basically, when I was talking about the undersea cabling, if you look at this diagram, this picture here on Google, this will tell you basically. Look at this. This is what. Let me see. This is the Pacific Ocean from the United States, from the California all the way to Seattle and everything. And this is basically your east portion from Atlantic Ocean, right? It's all the cables are kind of basically running in the ocean, going to Europe and Africa, and then from Africa also, it's basically running to Middle East, Southeast Asia, South Asia, and Australia like this. Right? And if you remember, like I think 10 years ago, there was a cable cut in Indian Ocean, and I think it took them like I think 4 or 5 days to route the traffic to some other cabling, right? Because the submarines basically go in, and there are companies out there which just they take care of these cables. So the connectivity to and between networks, I was just explaining, these are all intermediary devices. What intermediary devices are, basically from the user, this user over here. Where does that user go? This user, he has to go jump on the switch, and from the switch he has to go to the router, and from the router he has to go to another switch, and then from there it gets to the destination. We don't use hubs anymore. This is old technology. You see, the problem with hubs are, I'll show you here what the problem hub was. Hub is basically old technology. This is how hub and switch works. So if you have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You got 10 ports on this, right? I got a PC connected over here. Can everybody see it? Everybody can see it, right?
Yep.
Yeah, okay. If just in case I'm by mistake I press a mute button or stop sharing, just please let me know. So if I got a PC connected here and I got a PC connected on port number 7, so let's suppose this is PCA and this is PCB. And in between, there are some other PCs also, right? Like this. And this could be C, this could be D, this could be E. Now, the problem with hub is if this PCA wants to talk to PCB, he will be sending traffic to every single port on the hub. He will be sending it to everybody. And when the packet comes in for C and D and E, they look at the packet and they say, well, it's not designed for me. I'll simply drop the packet. And when the packet comes to B, the B looks at it and say, yeah, I'm the one this packet is trying to get to. I'm the PC, right? So what happens is when B wants to talk back with A, the B is going to be sending packet to E, to D, C, and A all. Again, C, D, and E are going to look at the packets and say, well, this is not for me. I'm going to simply drop the packet, my friend, and and voila. But from B and A is this is how they're going to talk. But this in the beginning, in 90s and mid 90s and everything, this was fine, right? This was no big deal because not a lot of PCs were on this on the network, right? But later on in 2000, switch was introduced. What the switch role was: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got a PC here, which is A, C, D, E, and B. What the switch does, it says, okay, in the beginning, when you reboot the switch, all these PCs are connected. And what happens is, if this A wants to talk to B, he's going to be sending to C, D, E, and B, just like the hub, right? But what will happen is, switch is smart enough. He's going to say, my friend, this port number 1 has got PCA, but this PCA MAC address. He's going to record this thing in a MAC table. Now, this guy looks at it. He says, well, this packet is not this time for me. He's going to drop it. D looks at it. He drops it. E looks at it. He drops it, right? When the B replies back and say, well, this packet is for me, switch is more smart enough. And he says port number 6 on this switch is basically your B MAC addresses. And you remember I just showed you over here what the MAC address is, the hardware address is this right here. Understood, guys? So he takes this and he says, for port number 6, this is my MAC address. For port number 1, this is A's MAC address. Now, the next time when the packet gets sent from A to B, there he switches smart enough and says, you know what? I'm not going to be wasting my time sending it to port 2, port 3, port 4, or port 5. I'm going to be simply sending it to port number 6 because that's where this MAC address is. Understood? But hub, no matter how many times this A wants to send the traffic to B, every time he's going to be sending the traffic to C, D, and E also PCs. And every time when the packet comes in, what it does, it will have to look at it, says where the source is, looks at what the destination is, and if it's not intended for him, and they're going to drop the packet. But what is happening is whenever the packet comes into the PC or a server or anything, it puts it into the memory. And when it puts it into the memory, he looks at it into the memory, and then he says, okay, let me see where the source is, what the destination is. So what is happening? The memory utilization starts to go up. The CPU utilization starts to go up. So this was slowing things down. That's why the switch was introduced. There's a lot of traffic going in and out. So let's just have this thing and then have this, create a table. And when I'm creating a table, basically, I know where these MAC addresses are. So first time when the switch, as I said, reboots, it will be sending it to everybody and acts as a hub. But the second time when A wants to send the traffic to B PC, he is simply going to be sending it straight to B, and he would not be wasting the resources on these 2, 3, 4 ports. So understood the difference between the switch and the hub? So
That is.
that's why we don't use this hub anymore. In mid 90s, I was working for IBM in the labs in North Carolina, US. We used hubs there, basically. But then later on, we start to move it to switch because was happening before was um, the 80% of the traffic was staying within the network. When I say within the network, means within your own LAN. Your server is local and everything. So it was staying within your own network. It wasn't going remotely. Remember I was saying, this is your LAN, this is your WAN remote connection. So 80% was staying within your network and only 20% was going to a remote location. But now these things have reversed. Now only 20% of the traffic is staying within your own local area network, and now 80% is going outside. Understood? And now this thing is going to go pretty fast, is because we are getting into this cloud and everything, right? Since this pandemic, everything is going to get uploaded to the cloud. You're going to have just the dumb terminals as when you go to the Food Basic and all these places. What they do, these are dumb terminals. They scan it, server is sitting somewhere else, it just looks up in the database, and then it says, oh, this is a price. Voila, it just comes up on the screen. So this is going to basically come later on, that we'll have dumb terminals. We'll turn it on. It gets connected to your cloud drive, and it downloads everything. So example number 4, network access device, hubs, switches, wireless access points. What is wireless access points? Is basically, let's suppose in your home, what happens? I'll give an example of Rogers, right? So as I said earlier, you will have a router at home sitting. If you look at it, you have a router sitting at home, right? That router acts as your layer 3, your router, acts as a switch, also acts as a wireless. When I say it acts as a wireless, is if you're sitting upstairs or downstairs in the basement or in the garage, basically you can have your cell phone connected on the wireless, right? But sometimes you don't get a good reception because you're a little far from that router itself, so you don't getting a good signal. So what Rogers usually give you, or if you want, you can go to the store and buy those boosters, right? And what this boosters does, these are access point. And what these does, basically, you get signal boosters. Understood, guys? I'm sorry?
So Imtiaz, I think these days they are moving to use the mesh network. If they have to use internal in the house or the building, if they don't have enough signals around the place.
I'm sorry, I just didn't get your question, what you're trying to say. When you say the mesh network, the mesh is basically, everything is basically coming into one pipe, right?
Yeah, everything is coming, the pipe and everything is connected to everything. So
Absolutely.
in
That's
the
called
house,
converged networks also, so my friend.
yeah. For example, Bell is using, if you have some, what do you call it, place in the house, doesn't get the signals. So they're using small devices. That's
The boosters, the signal boosters.
no, yeah, but somehow you can call it boosters, but it's not working as a what do you call it, wireless switches. Actually, is using the mesh connectivity. and then you install the small devices on the wall, and then for every floor you connect it to the next one, and then you get the whole signals through the house. If you have some places that you don't get enough signals,
That is true.
this is a new technology they're using in the building.
No,
So
I totally agree with you. That is absolutely true. I'm just calling it for easy language. It's kind of a booster kind of thing, right?
yeah,
You can even connect to that device upstairs or downstairs, but it gets synced up with your connectivity on your wireless router itself, which is sitting at a different location, on your main floor or somewhere else, right?
I have another question for you too.
Yes, sir.
Since there is a trend, most of the companies are moving to the cloud.
Yes, sir.
And we know the backbone of the cloud is based on this router switching, and mostly from the Cisco's. But what happens, because if the company is moving to the cloud, so they don't need to work directly with the switches and routers. So what happens now of people if they want to get a job in this area? So they have to
No,
work
no,
with the company Cisco's. So because the movement and trend and even the technology is going to based on the cloud, not directly every company keeping their own peripheral instruments to running the
no, no. I
network.
agree with you. I agree with you. But let me ask you something, my friend. If you're sitting in an office, you're hosting your applications in the cloud network, right? But your PC needs to get connected to something to go to the cloud network. How would you get connected to the cloud network? You have to go to a switch, and then switch has to get connected to the router, and then router will have to get your traffic to the cloud.
Yeah, that's I understood. Now, I said that if people that are learning switching, networking, routing, or this kind of stuff, such as CCNA, since this movement is over there, because the old technology, what old trend, I'm not calling it technology because they're using the same technology but different package. The old trend was every companies, the big ones, try to have their own network equipments. They have to try to use office, main office, and then branches, and then they have the connections through
No, no, I
ISP.
get it. I get it, what you're trying to say.
Yeah.
But the way you are saying it, it seems that everything is going on the cloud and nothing is going to be left behind. It's not going to happen that way, my friend. Trust
Mhm.
me. And the reason it's going to happen that way is because you see there are a lot of financial data out there and people do not want to put it on the cloud. A lot of banks don't want to get to the cloud. They have some basically hybrid cloud. They got a private and public cloud, but not everything is going to get to the cloud because you see that some information basically needs to be very privatized, right?
Yeah, but I mean, since I'm also involved with the cybersecurity, there is no 100% security on the
Nothing.
network.
Absolutely, there's
Yeah,
nothing anywhere.
so every data you have actually is going to work maximum 5 years maximum. Otherwise, you have to throw it out because you cannot keep things that going on as secure as is possible. And
No, no,
since
I totally agree with you, but let's not get too advanced at this time because I can have a chat with you after the class, but
okay,
there are a lot of people, I want to get them the basics of it, right? Because
yeah,
if you don't understand the networking, there is no way in the world you will understand the cloud,
yeah,
right?
okay,
So I'll chat with you later on, with a discussion on the cloud and how fast things are moving to cloud and how slow they are, which companies are moving. We can have a chat separately on this one.
okay.
Okay. Yes, switch have a MAC address table. It shows each port hardware. MAC address and updates the MAC address table, and when it comes to data exchange between the two ports on the same switch, and set a destination port which is showing the destination. So Syed Tabish, what are you trying to say here? Are you trying to explain exactly what I just explained, or is there anything you have added on top of it? I'm just trying to understand this from it. So the switch records the MAC address after the first time, so the next time there is a data exchange, it will send it directly to the destination by switching. Exactly, Almas. That's exactly how this switch is going to work, right? Okay. Hub doesn't have a MAC address table, but switch have keeps it on updating. But you have to understand one more thing, is basically when I say this thing right here, as I was explaining earlier, if this A and B stops the communication with each other, then this message, this table is put in a cache table, right? So different switches acts differently from different vendors, and what they will simply do, they will clear this thing out. If there is no communication, the MAC table is not going to be there, right? It's going to get cleared out. Understood, guys? If there is a constant communication going on between A and B, between 1 and 6, yes, you're going to have basically the, the communication and the MAC table built. So this cache is a temporary memory where it keeps basically this information. Or if you reload the switch, everything is going to be gone. Okay. Communication servers and modems, security devices, the firewalls, right? Firewall can be anything. So this is just a LAN, as I was showing you earlier, basically within your own site, and WAN is the remote. So this is just to show you this. An individual network usually spans a single geographical area, providing services and applications to people within a common organization structure, such as single business, campus, or region. So basically, this is, they're just showing you what LANs are and or what WANs are. So in this example, WAN is basically, think of it as a remote. This ISDN is no longer. Um, Last time I think I used ISDN was in, I think in 2000, right? Frame relay, I think we stopped using frame relay like in 2010, 11, 12 or something like that. Why? Because you see, ISDN is basically you're dialing into a modem, right? This is a backup for your primary connection. If your primary connection, which could be 1 meg or 2 meg, goes down, then what happens that we would be dialing into a modem remotely into a different device. Think of this as Toronto, think of this as Montreal. So what we used to do is if our main connection goes down, then this your ISDN would kick in. It's basically a phone line, and it would kick in and it will dial on the other side, and then you will have 128K. So 128K is a joke nowadays. Nobody would have, even at homes you don't have 128Ks. So this ISDN POTS line, POTS lines is still there because we connect to the network management routers. Frame relay is only 1.54 meg. It's useless. Nobody uses 1.54 meg anymore at work because 1.54 meg is such a small bandwidth speed, right? You can, do anything with it. And as I was explaining you earlier, because you see the things have now converged. When I say converged technology, you've got voice going in, you got videos going in, you got data going, your emails are going in, everything. Your data can be anything, your email, your files, and voice and video is basically if you're making a call, if you're having a conference with your co-workers or something like that. So everything is basically going through a pipe. So this 1.54 meg is not enough. So that's why, like when you get a 5 TV from Rogers or Bell, you're getting a TV also with them, or and you're giving a high-end internet. So what happens? They try to give you, like 200, 300, 400, 500 meg, download and upload speed, right? Download speed could be like 200 or 100 meg. So there's 1.5 for this old technology. ATM is like, I think it's 43, 44 meg. Now the technology, what technology people are using now is Gigi Ethernets. The Ethernets are using. So let's suppose I have got, so I'll show you to here. So basically, how this Ethernet works is let's suppose this. You have a floor, right? Your office. You got 7th floor, 6th floor, 5, 4, 3. you got an office over here. You got an office over here. And what happens is whenever they're making a building at the ground level, they have something called meet me room. This meet me room is built in condos also. If you go in a condo building at the bottom, probably P1, P2, you're going to have a meet me room or a phone room. And what they do when the building gets built, or in an office building, when the building gets built, they also have this. And what they do, the first thing they do, they bring the cables in, right? They bring their cables in, and they have basically the patch panels here, something called patch panels. And what this patch panel does, this is Rogers or Bell or whoever, or TELUS, whatever, right? And then from this meet me room, the cables are basically going up through the floors, and it's a big pipe, right? And these are called those pipes are called conduits. What these conduits do is basically take the cables from these patch panels from the ground floor, even in condo, even in your office buildings, everywhere you go, you're going to look at the bottom, P1 or P2 parking, you're going to have this meet me room. And then they run the cable across to all these floors. So let's suppose from the seventh floor, somebody calls and says, hey, Rogers, I need this 1 meg connection. No problem. They will basically through the conduits, they've already got cables coming up, and they say, voila, here you go, my friend, in your computer room, here you go, your 1 meg connection. Somebody calls from the sixth floor, hey, I need a 20 meg connection. Here you go. I'll give you 20 meg connection. Somebody says from TELUS, I need this. So all these guys are coming here, and once they basically try to run out of the speed, then they basically run another circuit. They expand it instead of from 1 gig, they make it a 10 gig, right? Because they get subdivided. And through conduits is basically going up. So if this happens in the condo building, this happens in the basically office building also. So the service provider or telco, it's the same thing. ISPs, you call them ISPs also. So they're the ones who are basically responsible for connecting to different sites. You are responsible from this, connecting from the users to the switch to the router, and from the router onwards, it's basically their job. So if as I was saying earlier, if I have an office in Toronto and I've got an office, let's suppose in Germany, so what is the, and I've called Rogers and I say, hey, Rogers, can you give me connection between the Toronto and Germany, right? And then what happened? You think that the Rogers have an office or Rogers have the infrastructure in Germany? No, they don't. They will say, okay, we'll charge you, let's suppose hypothetically, $1,000, right? So they charge $1,000 to give you a connection here and to give you a connection in Germany. But what Rogers do, the Rogers will turn around and then they will give it to Deutsche Telekom or any other local telco. They will give them some money and basically they have agreements in between, right? That if my customer comes into your country, I'm going to be giving you this much for this much speed. When the company in Germany tries to come into the Canada, then basically they'll be giving probably getting Rogers or Bell, because you see in the east of Canada, this Rogers and Bell, they have got the all infrastructure built. When I say infrastructure built, underground cabling. When you go to the west of Canada, it's all TELUS, right? And so basically that's where they have the infrastructure all built. So when the TELUS wants to come in and they don't have the cabling, they, like, let's suppose I hire TELUS. So basically I'm paying TELUS $1,000. TELUS will basically give me a connection in Toronto, but they don't have the infrastructure. So they will simply go to Rogers or Bell and say, hey, you know what? I need this much bandwidth. Whatever, 500 or 200 or 300, they're going to pay them, and then and voila. This is how all these telcos, they are talking to each other all around the world. It's not just locally, it's all around the world. Okay, connecting builders, dedicated lease lines, metro ethernet. This is the ethernet. Satellite, I don't know. I used last time the satellite connections in 2000, in 98, 99. Horrible connection. Why? Because when the weather goes bad or it starts to snow, it starts to rain, you'll have a satellite drop, right? I've not worked in the last 20 years on satellites, so I don't know what the advancements are. Whether, must have got better, not worse. Converged networks, as I was saying earlier, converged networks is all different kind of technologies merged on that one pipe going across. That's what converged networks means. Your messages are going, your email is going, your phone is going, like your voice, and you're having also your videos going, right? So that's called converged networks, means combining together, combine together. Packet switching, fault tolerance. What is fault tolerance? Fault tolerance is if I'm this person and I need to I need to access this server here, how many paths or how many hops do I have to get to him? Now, if you look at it, this is my router. I can either go here to this router and come this way, or I can come this way. I can come this way, or I can either come this way, go up, then come down. From here, I can come to this router and go to this router. So there are many ways I can get to the destination. Now, there is something called routing protocols and static routes. What routing protocol does, it basically says, okay, if I've got 4 or 5 routes to get to the destination, I'll probably use this path as the primary, and I'll use this path as the secondary, my backup path. In a static route environment, what happens, you as a network admin, you are saying, in order to get to this destination, make sure you take from here to here and from here to here. Do not basically go this way or any other way. Understood, guys? So the fault tolerance is, in this environment, they're saying, if the primary path, let's suppose I started communicating with the server through this path, right? Now, somehow this connection gets dropped. No problem. I have other paths also. I can go this way. I can start going this way. I can come from this to this router, from this router to this router, and this router to this router. So I got backup paths in order to get to the destination. So the fault tolerance means if your one path fails, then you have a redundant path. You have a secondary path in order for you to go. Understood, guys? Packet switching, share the same circuit, multiple redundant circuits, but each circuit is shared, limited number of circuits, but shared. This is what they're talking about, that these are basically different ways of getting to the destination and everything, different hop counts. Scalability. Scalability means that it's how can you grow? Scalability, a scalable network can expand quickly to support the new users and applications without impacting the performance of the service being delivered to existing users. So scalability is let's suppose I have a site. In one site, I have got only 10 people sitting, right? And basically, if 5 or 6 or 10 more people gets added, do I need to put more hardware? Am I scalable? Can I expand or can I reduce? So that scalability is, if you have new users coming in, then you have an infrastructure to grow. So whenever you design a network, you just don't say, okay, you know what, I've got only 10 people sitting in my office. I'm only going to put a switch which can support 10. What like after 2, 3 months or 4 months, somebody else gets added to it, right? Then what you're going to do? You're going to change the whole switch again, right? So you don't do that. So you want to basically design a network in a way where when you want to expand, you have the scalability, you have the space. Okay, comprende? So a scalable network can expand quickly to support new users and applications without impacting the performance of the service being delivered. So if there are 10 people sitting, put a 24-port switch. Now, quality of service. What is quality of service? Quality of service is basically saying, I'll explain it this way. In a work environment, when you are having basically a conference call, or when you're calling somebody, basically you're using a voice over IP, or when you're having a basically a meeting, you know, what what happens is basically when you're having a meeting, you're having a video meeting, you basically prioritize your video and voice. So in your home environment, what happens? In my home environment, when I'm having a video call with somebody back home in Pakistan or anywhere, what happens? My packets come in, and then my packets go to the destination, and then first in, first out kind of way. If the network connection is bad at the destination end, what will happen? My packets are going to get dropped. My video is going to go bad. My voice is going to go bad. I'm going to have to repeat myself. But in a work environment, there is something called quality of service. What quality of service does, it says if I have a bandwidth between source and destination with 10 meg pipe, I will say make sure 50% you basically assign to my voice and video, and the rest of the 50% use it for my file transfer, use it for my email transfer, whatever that is. Understood, guys? So quality of services, make sure my voice gets sent first, my video gets sent first, and then my email and then my other data go across. That is a big difference between our home when we talk to somebody back home on WhatsApp or anything. There is no quality of service in place there. It's just FIFO. FIFO is first in, first out. Whoever comes first will get out and get to the destination. So your voice is going, your video is going, somebody's playing games, somebody's watching TV, somebody's working on the laptop. It's just everything gets jumbled up and sent across. But in the work environment, it's a different whole ball game. So they basic work environment, they're using this quality of service in order to make sure that they whatever the pipe is, 10 meg pipe, they want to make sure that the 50% of that is only dedicated to your voice over IP, right? And the rest, basically, you can use it for anything else. So this is in the beginning, the voice over IP was very, choppy. Calls were getting dropped, and video was not working properly. But then they started to brush up this quality of service, and get start implementing, and they get, and more advances. Now basically people are having connections of, I can pick up my work phone, I can call anybody in US or in Europe or in East Europe with no charge. Everything is just going through my work, pipe. Understood, guys? iOS. Now, I'm saying Cisco iOS, but I work on Juniper, Arista, Sienna, all these white boxes, Cisco boxes, right? Everyone has iOS. What iOS is like an operating system on a network device. Could be a switch, could be a router, could be anything, right? So what this iOS does, it basically, let's suppose I want to buy a Juniper, I want to buy a Cisco router, I want to buy Arista, I want to buy Sienna, or any other vendor XYZ out there. So when I buy the hardware from them, I call them and I say, look, I'm more related to security. They said, okay, you buy this iOS or this software which gets installed on your network device. Somebody else says, you know what, I am with I need the security features in it, but basically what I need is more voice and video features. It's okay for you. You use a different iOS, a different software to download on your hardware, your routers or switches. What will happen with this? If the guy who has downloaded an iOS or software, just like your Windows 10, your Windows 8, whatever you want to call it, on your PC. So this Windows 10 and Windows 8 is basically just like for your routers and switches. So if someone has bought an iOS or software for their hardware, for their router and switches for videos and voice, and what would happen is they will get more features for the voice and video. They will still have the security, but they will have more features for voice and video. I, on the other hand, If I have bought something for security, what would happen is I will have more security features in it to configure my router as per the security requirements than the guy who's having a voice or video. Understood, guys? Yes? No? Could be? Might be? Anyone has said anything in the chat? 756. Just a suggestion. When you have a question, please start your conversation with the word question. This will help. Understanding whether you're asking question. Yes, please. That's a good idea. That's a good idea. Or because when I'm teaching something, sometimes I don't know whether someone has written something in a chat. So just ping me for a second, right? Just say, hey, excuse me. Just say, excuse me, and I'll just look at it, right? Because I'm just going in the flow, so I'll probably not look at it. Okay. Protocols, human communication. Now this, guys, for how long do we have a class for? From 7 till what? 8:30? Uh,
Yes, up to 8:30. That was what the initial suggestion. But it's up to you if you wish to do it
no, I don't
according.
want to like bombard with all the information. So I'll probably stop in 5-10 minutes and then I'll take your questions. Okay.
Sure.
I'll just go over this DNS for a second, and then I'll stop. And then if you have any questions, then we can go over this. Okay. Um, I'm gonna go over OSI and TCP/IP later on, but just for now, um, let me ask you something. The DNS, the domain name system, it's called. What is DNS used for, right? So if you look at this, so basically the DNS server, all it does, domain name system, all it does converts name to IP address. That's all it does, right? When I say name to IP address, what am I talking about, right? And remember I said earlier that when you are communicating on the internet doesn't know what bbc.com is. Internet doesn't know what cnn.com is. It does not make any sense for the internet, for CNN or BBC. They don't know it, right? Everything, remember I showed you here, everything has an IP address. In order for you to communicate with a server, you have to have an IP address. If you don't have an IP address, you will not be able to connect to it. So what DNS does, it maps basically the bbc.com to an IP address. I'm going to explain IP address later on, guys. It's a whole different ball game. This IP address right here, right? Every device would have one IP address. Now, don't get fooled by this. When I show you this, bbc.com has got only one IP address. This is impossible. You guys might be, I'm not a Windows guy. I taught Windows in 97, 98. I was a Windows instructor for Windows NT. After that, I didn't work on Windows. I worked on routers, switches, firewalls, and everything, right? So this bbc.com has got IP address, but don't get fooled that it's got only one IP address. If you think that BBC, millions of people are going, let's suppose 200,000 connections are going to bbc.com. You think that there's only one IP address facing the world and that's it? Only one server sitting there? It doesn't happen that way. This IP address, which one was that? 150, let me just see, 151, 101, 124, 151, 101.104.28. They're saying this bbc.com gets translated to this IP address. Who does this translation? This puppy right here, this DNS server right here, which does all your translation. I said youtube.com, gets converted to the IP address. I said yahoo.com gets converted to an IP. Everything has an IP address. Without an IP address, nothing will exist on the internet. Internet routers only work on IP address. It does not work on any naming convention. So this DNS server is the one which basically tells you what the bbc.com IP address is. Understood? But again, I'm going to get into later on this. But remember this, I'm showing only one IP address for this bbc.com, but this is not one IP address, guys. There's to the world, they're saying this is the IP. But when you send the traffic to bbc.com, the server turns around and they might be doing a round robin or load balancing, and they might have got 10 or 15 or 20 or 30 servers sitting behind them, right? To the world, they're saying this 151.101.104.28, but in the back, they have got more servers sitting, and they're doing basically a round robin thing in the back, right? Because hundreds and thousands of people are going to basically bbc.com in the east of the Canada, or this could be in the west, east of US also. Understood? So that's what DNS does. We're going to get into DNS later on in more detail, but just for now, understand the DNS, what it simply does, it takes a name and it converts it into an IP address. Because everything on the internet works on an IP address. Comprende? Good. Okay, I'm going to stop here and I am going to give you guys a chance to ask questions or anything. I think somebody else asked me about the VPN and I said, hold your horses on that, right? I think somebody asked me about VPN, if I'm not mistaken. So basically VPN, what VPN is, it's a little, guys, this is not part of this because VPN is a whole new, is completely different thing that I'm talking about. It's a little high end. Let's suppose you have a router at home. You got a PC here, and basically it goes to your server at a remote location. They've got a router here, and basically you got VPN concentrator. You have got a software running on your system. When you start the software, what happens? It asks you for your code. You put your username, and then you put your password plus your soft token password. And what happens? It goes through the internet, it goes and connects to the VPN concentrator. And what VPN concentrator does, on the back of it, it goes to a server and it gets authentication. Once it authenticates you that yes, you're the correct, you have the correct username, you have the correct passwords, you have the correct soft token. Basically, once it authorizes you, then you are able to connect to your work environment. And everything, and there is a pipe, a virtual pipe gets built between this and your work environment, and everything which goes across, it goes across encrypted. What encrypted it? A clear text, right? Plain text gets converted into a clear text, basically encryption mode. And what encryption does, it basically, it all jumbled up, right? It doesn't go in a plain text out on the internet. So through this encryption, it gets basically sent across and you get connected to your work environment. That's what VPN does. Virtual private networks is basically a concentrator you get connected. And through that concentrator, sitting in the back is basically your authorization servers, which will check your password, will check your soft token, will check your username and everything. Okay. That was one of the questions. What else, guys? So that has been first time. So any other question, guys?
So Imtiaz, well, since I came as a guest, I don't know why, so I'm not able to type the questions because it's disabled. So I have to type.
You cannot
Oh,
type.
Wahid, I will look into that, Wahid. Okay.
Yeah, thank you.
Yeah.
But I have a question for you. Is it also possible for you to help us with the exams or test questions while we are studying that we can also prepare right away in the same time.
What's in your mind though? What are you trying to do?
Well, I believe everybody is going through the course. They want to be certified as a CCNA.
I doubt it. I
You doubt
seriously
it?
doubt, because yes, I seriously doubt. And the reason I tell you why I doubt it is because I cannot cover every aspect of the CCNA or a networking course in 40, 50, or 50 hours, tell you the truth. Because I teach part-time at Humber College, right? And I'm teaching currently the Cisco networking course, and I'm teaching the cybersecurity course, and I'm teaching the Security Plus course also at Humber College on Saturdays. So and basically my courses run for 3 months and 8 hours every Saturday,
Mhm.
right?
Yeah.
So it's going to be next to impossible for me to cover everything in 40 hours. Tell you the truth, there is a lot of information on this, and the thing is that not everybody, because when I looked at the document, when I looked at the Excel spreadsheet, not everyone basically is IT. A lot of people are basically in insurance, some are basically doing this or doing that, but they're trying to understand networking from the front, from the ground up. So if they are interested, then they can join some institute and try to learn more. If they see that it's not their cup of tea, then they'll probably jump into something else,
Mhm.
right? So not everybody in this class is basically on that level where they're experts. Most of them, I've noticed, 70% I've noticed when I was looking at the Excel spreadsheet, that they're trying to get into networking and they're trying to understand their nuts and bolts first.
So this course is going to make you or enable you to understand if networking is the field which you can proceed further, and definitely we can give some more guidance on it if required for those specific persons who are interested in taking CCNA course or CCNA certification. Thank you.
Another question is, I have noticed the whole concept of the CCNA, CCNP, CCIE has changed. Recently, I checked the Cisco's website. I've seen they have changed so many things. I mean, it seems that you have to take three type of the CCNA before you move to the higher level. So how is the
It has
test?
always been there, my friend.
Yeah.
It has always been like that. Before they had four, now they have made it three. But what they have done, they have combined those four into three,
Mm.
right? So don't think that they have taken some things out. They have not taken things out. They have just basically combined it and added some more stuff in it. Not too much, but added some stuff in it.
Because as I understood through the website, it seems that you have to take three type of the CCNA before you move to the higher level. That's what I understood.
Mm,
Because before that, if you wanted to go to the only router switching, you were getting CCNA, and then you're going to CCNP for the router switching, and then higher level. And there were 8, 9 branch of different type of the Cisco's what do you call it, knowledges. So, but the main was 3 level. So you were getting CCNA, and then you were, if you want to go to CCNA voice, you were getting CCNA routing switching, and then CCNA voice, and then CCNP voice, and then you go
no,
on higher
no.
level.
I would not take that route. It's a waste of time to get CCNP
So
voice
what do
or
you suggest?
CCNP. I do not suggest that. CCNA, I recommend everybody. The reason I recommend is, no matter you want to go into security field, no matter you want to go into cloud, no matter you want to go into cyber or anything you want to go to, your network understanding has to be there. Understood?
Yeah.
You have to know the networking. Then your 40% of the problem is going to get resolved. Everything works on networking, right?
Yes.
So 40% is basically, that's what I say, that it's better to understand the networking and then jump into voice, then jump into your voice over IP or security or whatever you want to get into.
Mm.
Understand?
Yes. But I
Okay.
mean, my question was is because when I was checking the Cisco's, they have totally changed the design of educations. So that's why I was at this question.
No,
So
don't
maybe
worry about it.
yeah.
Don't worry about it. Don't jump on CCNP, is my suggestion is. Do your
So
networking and then jump on CCIE, or you wanted to jump into cybersecurity, or you wanted to jump into cloud, then do Azure, AWS, whatever you want to do. But no matter what you do, you need to have a good understanding of networking, my friend. That's the
yeah,
whole thing.
since I'm involved with the cybersecurity, so if I want to come to the technical level, because the cybersecurity I'm working is the management level, it's not the technical level.
But you
So
have to understand the technical also. I'm not saying a complete hands-on, but you need to have an understanding, because you see, when you're talking with somebody, it's in the cybersecurity, as you're saying that you're in, but if you're talking with somebody and trying to explain them the issues, if you don't know the networks, how are you going to be explaining it? You're never going to be having explaining somebody the big picture till you understand what the local picture is.
well, you know, I was getting the cybersecurity to the York University. I mean, so since this is a management level, they were mentioning that you don't have to involve with the technical level. You have to have
Okay.
some understanding, but not the details, because the
That's
details you have,
exactly Wahid, what I'm saying.
yeah.
I'm not
So
saying complete
yeah.
hands-on and understanding every nuts and bolts, but
Mm.
at least have an understanding of networking. That's exactly what I've been telling you, my friend.
So what is your suggestion? If I have to take this CCNA, so what step I have to take for the security
It
part of
it
technical
all
part?
de- it all depends what path you want to take. You want to take voice over IP, you want to take security, you want to take cyber, which path you wanted to take.
Is a security. That's my primary path is because I want to combine both in management level and technical level. So it's
So that's
good to
good.
have a,
So that's good. You're already doing from York University, and you already have doing CCNA. What else you want?
no. I mean, the first step I have to take the CCNA networking and router switching, and then what is the next step after this? If I have to continue with the security part
You wanted to go into firewall, you wanted to go into the cybersecurity.
to cybersecurity.
Then you're already doing a course, as you said, right? From York University.
Now, I have done it, but that was a management level. I mean, it's a CISSP. I mean, you have to be certified if to get the certifications. You get the CISSP
Yes.
certifications. But that's, as I said, that's the management level. But if I have to involve myself to technical level, so I need to
Palo Alto firewall. Do a Palo
certify.
Alto firewall to Azure security, that kind of stuff. Combine these skills together.
So after CCNA, what will be the next step? I mean,
If you want to get into the cloud security and everything, you're already doing CISSP, do your Azure security.
no, Azure is different because in beside I'm also working with the Amazon AWS.
Do
So
AWS then.
yeah, AWS. So
Do AWS, whatever you're trying to do. Look, there are so many things you can do in cloud. There are so many things you can do in security that you cannot just simply pinpoint and say this is the only way to get to the destination, what you want to go, your goal, whatever your goal is, right?
yeah.
So there are so many paths. So right now, understand the networking and slowly build, and then see what you want to go to, what you like.
I see.
You already got your CISSP, right?
No, I'm working on to pass the test. So I'm just need a few weeks to do it because it's a big
That's good.
exam. It's not
That's good.
easy one.
Okay, that's good.
Yeah, yeah.
All right. Okay. Any other question? I see some raised hands. I don't know. Tabish and one more person. I don't know who that person is. Any
Hello.
questions?
Yeah, can you hear me?
Sorry.
Can you hear me?
Yes, I can hear you, but it's a little low right now. Your voice. Speak a little bit louder, please. Okay. I guess not.
Is it fine?
Okay. Let's just speak and then I'll see if I
Yeah.
can figure it out.
Yes, sir. I have a question. Like, for example, like I'm interested in appearing at the So can I have the material like the dumps and stuff like so that I can prepare myself from
The brain dumps
there?
you're saying?
Yeah,
I'm sorry. You said brain dumps?
yeah, yeah. The
No, the brain
brain.
dumps, I don't have it, my friend. You will have to buy the brain dumps from online.
Okay. So like, is there any tips or tricks that can help me the
Any
right
what?
dumps? Because like any tips so that I can have the right
If
place
you
in
have
the
an
right dump?
understanding of networking, if you have a good understanding of networking, then I suggest you get the dumps. But I don't have any way of confirming that those dumps are valid. You have to check on Google to see which dumps are good.
Okay, because people are saying like when you prepare for the exam, you just need to make sure that you are buying from the right place because sometimes they are expired and stuff. So I was pretty much confused. I googled it, but I'm not sure from where to buy it exactly and how much accuracy they have. So
This
I
is
was
this is
just
always a
puzzled up
problem.
between these two. Yeah.
There's always a problem. Nobody can guarantee it, my friend. That's the problem. You know.
Yeah, yeah. So, like, is there any specific site or something that I can
I
follow
can
to?
try to search for you. You can search online too, but I can try to see if I can find something. Okay.
Okay. And for that, do we need to get it registered from VUE's platform so
Yeah,
that to
Pearson
get
View.
the,
That's
yeah.
basically where you go and take the test.
Okay. And one more question, like the dumps are usually saying like they have 450 questions around. So would it those be like the sufficient enough to that cover the entire exam that will be
Some dumps
upcoming?
I've seen there are 800, 900 questions out there.
Yeah, yeah,
So,
exactly.
I cannot say that this would be sufficient or not. So I cannot tell you the truth. I really cannot say anything about it.
So yeah, like so, what would be the best thing to like prepare for the exam? Like what would be the
My
best
my thing
activity?
is, if you have understood the topics, then all you need to do is basically, get the dumps, go over them, and go and sit in the test. But
Yeah.
there is no guarantee anywhere to say that these dumps are better than this dump or this dump is better than that one. That's what I'm trying to tell you, my friend.
Yeah,
Okay?
because when I just calculated, it's around almost $500 plus amount
Tabish,
to be
talk
invested.
with me later on Telegram about this.
Yeah,
I
sure,
can give you
sure.
some insight about it. Okay,
Okay, sure. No worries.
Zia.
Thank you.
Okay.
Anybody else? No other question, guys? Okay. Thank you for joining. I'll see you guys on
So,
Wednesday. Sorry?
Same time.
I have a question.
Yes, sir.
A
Same
very
time.
quick question is about the Cisco, the competitors of Cisco. Like what we see is that we when we want to learn about network, we always go with CCNA or Cisco route. Why is always it has to be Cisco? Is there any other competitor or any other
Juniper?
company? Yeah, Juniper is there exactly. So, do they also have these courses? And second question would be that if we are going through Cisco way of learning, let's say, will it also help in Juniper and other technologies?
Because I work on Cisco, Juniper, Arista, Sienna, and all these other vendors, right? Concepts are exactly the same. Commands are basically not exactly the same, but commands are a little different, but the concepts are same. The format of the commands are a little different, but the output is like, if I want to look at the interfaces on my router, I can do a show interface command on Juniper, but basically on the on Cisco, on Juniper, I'll just do terse interface terse, right? So there are a few things here and there they have to change, but output is basically the same.
Thank you.
Look, you have to understand this, guys. I'm getting a lot of feedback, but I'm not going to be teaching CCNA. This is, let me be very clear about it. CCNA is basically, I cannot teach CCNA in a 40-hour period. As I said earlier, there are a lot of people who are basically, I'm going to lose if I start to go from Cisco level up. I'm going to be explaining things in order for you to get the foundation and understanding the fundamentals of networking. Then basically those who have understood the fundamentals, whether they want to decide to stick with networking or they want to decide to do something else, right? So this platform is just to give you an understanding and give you fundamentals. Those who wants to pursue basically the higher, you know, don't expect that the whole CCNA course will be covered here. So that's what I was saying earlier, that my courses at Humber, they run on Saturdays for 8 hours. I start at 9, I finish at 5 o'clock. I teach the networking, I teach the security plus and cybersecurity also, right? And I run it for 3.5 months. Okay, so hopefully you can understand the questions, you can understand the concept, and those who wants to pursue it, let me know if I can be of any help later on after class or something, right? Send me an email, that kind of stuff. Okay,
Thank you very much.
thank you. I'll see you guys Wednesday then, inshallah. Right.
All of you are requested to download the book which is there on Teams. You can see the wiki page, and you will be able to download the book from there. And the course material is also mentioned there. So please have a look, have a go through that, and so that you are prepared for the next class also. Thank
Okay,
you.
guys, take care.
Thank you very much, Hassan
Thank
भाई,
you.
बहुत बहुत शुक्रिया आप लोग का. Thanks.
Shukriya.
Thank you.